This video is on beta decay equations. It follows a video from alpha decay equations. If you've not watched that one, feel free to watch that one after this. So beta decay. Beta particles, have a little think. What do we know about beta particles? Well, a beta particle, of course, is a high speed electron. It is much smaller than an alpha particle. Alpha particle, remember, is made up of 2 protons and 2 neutrons. It is a helium nuclei. Beta is just a single electron with a negative charge. So because of this, we can describe it in terms of ionization and penetration and compare it to the alpha particle. So it is less ionizing than alpha because it's smaller, less likely to knock off electrons, but it is more penetrating. It can actually travel a few meters in air, and it can go through skin and paper, unlike alpha that is stopped by skin and paper. In fact, it's only stopped by a thin sheet of metal. So where do these electrons come from? If I asked you to describe an atom and you told me where electrons are, you'd probably say that they are in shells or orbitals around the outside of the atom, of the nucleus, and you would be correct. However, the electron that comes high speed from an emitting a particle is actually from the nucleus. And what happens is we have an unstable nuclei. Remember, that is some key terminology there. We have an unstable nuclei, and it contains more neutrons because of that. It is probably like to be an isotope. And an isotope number is described as forms of the same atom with the same number of protons but a differing number of neutrons. So we have an unstable isotope, and it's emitting beta radiation randomly. So because it has too many neutrons, it wants to change that neutron into a proton. So what happens is we have a neutron, and part of the process is that it emits our high speed electron, and that is our beta particle, but also that neutron will turn into a proton. Now, there's a couple of things we have to know about this, and that firstly is that the relative atomic mass of a neutron and a proton is the same. They both have a relative atomic mass of 1. And that's important when we talk about the decay equations. So, when we talk about the decay equations, it's important to think about the atomic mass and the atomic number, just like with the alpha decay equations. So at the bottom here, we've got iodine 131, helium 6, sodium 24, and so on and so forth. Let's have a look to see what happens when we have an iodine 131. It emits a beta particle. It undergoes radiation. So the iodine here emits our beta particle, and our beta particle has a mass of 0, but it has a proton number of -1, and that'll become clear why in just a second. Remember, just like alpha decay, the atomic mass and the proton number must be the same on both sides of the arrow. So the atomic mass must be 1, 3, 1. And we can link that back to what's happening here, because we have a neutron that's sent to a proton, so the atomic mass has not changed. However, we have gained a proton. So the proton number increases by 1. So the proton number here for iodine was 53. So the proton number for the element that it would decay into will have 54. And we look at our periodic table, we can see that is Ze. We'll do one more together. Helium. It emits a beta particle. The new element it gets turned into must have an atomic mass of 6, but a proton number of 3. And when we look at our periodic table, what element has a proton number of 3? Well, it's Li, it's lithium. Remember, lithium and all of these, all right, always go for the proton number. The atomic mass may not be the same as what you see on your periodic table because they are isotopes. Now, pause the video here and have a go at looking at sodium, potassium, gold and Fe, these 4 examples here, and each of them will emit a beta particle, and have a little go at working out what they will be turned into. So pause the video and have a go. Okay, so you should have had a go at each of these. Now each of them will emit a beta particle. Now you sometimes might see the beta particle written something like that, so it's an electron. Sodium turn to magnesium. Got Ca, calcium. G, mercury. And CO, cobalt. So the way to remember this is that when we have beta decay, the element that gets turned into, we just look at our periodic table and we just go ahead one. We move one element to the right because we increase our proton number by 1. So what we need to remember really for beta decay is that the atomic mass stays the same. However, the atomic number will increase by 1. I hope this helps you understand a bit more about beta decay. I will do some more examples soon, past paper examples with alpha and beta decay about what is expected in these calculations. Good luck.